Hello and welcome back to my channel. This is Bright. If you haven't subscribed or if today is your first time, you are new here, you can like and then subscribe to my channel. In our previous video, we looked at remote sensing, where we learned and we saw how remote sensing works, how the sensors are able to capture the reflections from the earth. We learned the active and passive remote sensing, their application in our daily lives. Today we are going to look at remote sensing and GIS, how they complement each other. Many people know GIS, remote sensing, but they can't really tell the difference and know which one does which one. And so today we are going to see how they complement each other. Now, we have the GIS. And GIS is just tool for storing, analyzing, and visualizing spatial data. And the last time I talked about spatial data, where I said they are just fixed locations on the earth. So these fixed locations like road, like water bodies, like trees, they are not moving. Though the earth is moving, the earth is not moving, leaving them behind. The earth is moving together with them. So those are spatial, geospatial locations. Now, when the data is being acquired from these areas, they become geospatial data. So GIS just stores, analyze, and visualize them. Remote sensing, on the other hand, is just the technique to capture the Earth's data from space or airborne platforms. Airborne platforms like the drone, the UAVs, the helicopters, the flights. Those are airborne platforms. While the space, we are talking about the satellites and its allies. So remote sensing just captures the data from such areas, and it just uses sensors to capture. So together, GIS is the brain. That is it. GIS is just the brain. GIS is just the brain. Whereas the remote sensing is the eye that sees and capture. So whilst the remote sensing sees and captures it, the GIS processes what the remote sensing has captured. So if the remote sensing captured the water, what is the water body being used for? GIS will draw meaning to what the water body is being used for. Whether you'll be doing erosion and then accretion analysis on shoreline based on the remote sensing data, then you can do it. So the GIS is the brain. The remote sensing can provide the land use, land cover data for you, whereas the GIS will interpret those data that the remote sensing gives. So GIS is the brain, the remote sensing is the eye. So this is just a diagram to depict what I was saying. So GIS is here, remote sensing is also here. The remote sensing will provide the data for the GIS to process like this. GIS will also analyze the data to prove what the remote sensing give. So the remote sensing give us, let's say, land cover change data. The GIS will interpret it to draw meaning to what the remote sensing gave, and that is what they both do. So they complement each other. Now, how do they complement each other? Let's talk about the data source and analysis tools. So the data source, what remote sensing does is that it only provides the imagery, the vegetation, the temperature data. So it's going to just capture. It's just going to capture. It doesn't analyze. So remote sensing doesn't analyze. It only remote sensing is just capturing. It's just capturing. It's just bringing out the data. So what the GIS does is the GIS will also interpret the temperature. So let's say remote sensing will give us data that maybe in Accra there's flooding. What are we using it for? The GIS is what is going to give us the typical location where the flooding is. occurring and what brought about the flooding. So GIS, the remote sensing will tell you that, oh, there's flooding in maybe Accra, some parts. Then the GIS will process that data to find out which actual location the flood is occurring, and then also look at the possible damages that has occurred. So the data source and then analysis too. Then we have multi-layer analysis. So remote sensing can be, so the first one we can look at some example like monitoring land use, land change over time. Yes, so you can pick the satellite images. The satellite images are just with bands, and in our subsequent videos we'll look at what each band does. So you pick maybe Landsat data, pick that Landsat data, then you use GIS to analyze the Landsat data, and then know that, oh, okay, in 2004 this place was used for vegetation, but now it is just being used for construction. So you can look at the change without being there, without, maybe you've never even gone to the place before, but remote sensing has given you the data to be able to perform that analysis. So the analysis too. The multi-layer remote sensing data can be layered with other data like the routes, like let's say the polygon files, maybe area of interest, to know typical locations, to draw relationships between what is happening. So you can use it to do, let's say you have temperature data, you can layer it with another data of coordinates. So you have picked coordinates of a particular location, you know the temperature of the particular location, you can layer the temperature with the coordinate to know the actual places where the temperature changes is happening. Then you can do spatial analysis, so you can look at the relationship. Okay, this particular place here, this is what is happening. So the coordinates can be layered with the remote sensing data like the temperature to know, like combining NDVI, like I said the last time, the normalized difference vegetation index, the NDVI. You can layer it with or combine it with rainfall to look at aggregate zones. So let's say NDVI, we are looking at the vegetation index, the color changes of the, maybe looking at this particular place, the plants over here are having color yellow, maybe it means they lack maybe potassium. Okay, they lack potassium, or let's say it is very rich in calcium. So this place is very rich in calcium, and then also the soil is telling us that this place has a lot of it has low permeability. That means water is able to it is able to hold water for a longer period of time. So since it is able to hold water for a longer period of time, and it is also rich in calcium, then which crop can we use to cultivate? So you see, we have been able to combine the NDVI with the soil to know which type of crop we should plant at a particular place, and that is what multi-layer analysis does with the remote sensing. Real-time monitoring, a very key thing. Real-time monitoring, so that the remote sensing can capture the data, can capture the, let's say, the road, or maybe the water body, can capture even the vegetation. When you bring it to the GIS will be able to tell you the actual location. So you can process it using the GIS, so that whilst you are moving, you are knowing your real-time location, like what it does with the Google Maps. You see that Google Maps, you can look at satellite image, and then the satellite image, you look at your real-time location. So whilst you are going, you are knowing that, okay, this place there is tree, this place there is ramp, this place there is road, this place there are buildings, this place there is a hotel. How are the Google team able to know that there is a hotel over here whilst they've not been to the particular area? They do not have representatives over there. They only use the satellite images to know that there are hotels and the information they get from the satellite image, so that your real-time location, they can tell you particular areas within the particular places within your area where you can benefit from. And that is what the real-time monitoring does. And then it enhances visualization. It enhances visualization. So the remote sensing will provide the data, but the GIS will enhance the visualization. It's going to add some color changes. It's going to crop, or let's say clip it. It's going to clear the clouds to enhance the visualization of that data. So they complement each other. The remote sensing itself cannot remove the cloud. The remote sensing itself cannot do the atmospheric change. The remote sensing itself cannot clip it to a particular location. The remote sensing itself cannot even digitize some locations. So it is the GIS that will do all these things to enhance the remote sensing data. And then accurate change detection. So let's say you want to do shoreline analysis. The remote sensing can only give you the image of the particular location, but it is the GIS that will be able to tell you that from these three images, maybe the 2000, 2010 and 2020 data you have given to me, between 2000 and 2010, maybe there is erosion, but from 2010 to 2020 there is accretion. So it is the GIS that will be able to interpret the data that you have acquired from the remote sensing. So the accurate change is being done by the GIS, but the data for the input is given by the remote sensing. Here you look at a real world example. In Ghana, Sentinel-2 imagery and QGIS were used to identify illegal mining zones by analyzing vegetation loss. So maybe in 1990, this area there were a lot of vegetation. We did another analysis in maybe 2005 and we saw that there has been a lot of vegetation loss. So the vegetation loss, we check in, but the population over there has not increased that much. So how are the vegetation being lost? If the population is increasing that much, they can say that okay, that place is developing. But the population is not also increasing that much. That means there is something wrong over there. So going to check, then you realize that, oh, okay, these places are being used for illegal mining. You can't be able to know where illegal minings are. You can't walk through even some places are in typical bush. But with remote sensing data, you can easily know that, okay, these places are being used for illegal mining without even being there. So knowing then, you can know that, okay, these places are being used for illegal mining. So we can prepare ourselves and go and then stop them. And that is what the Sentinel-2 imagery was used to identify illegal mining zones by just analyzing vegetation loss, which led to land management efforts. So finally, let's look at the common application. In agriculture, crop monitoring, like I said, you can combine with you can layer or combine, let's say, the NDVI with the soil data or even rainfall to just know the type of crop, and it helps. You can also use just the NDVI from the remote sensing, bringing it to the GIS. You can monitor the crop by just knowing the color to know that, okay, this crop is deficient in potassium, calcium, or maybe phosphorus. You'll be able to know. Yes. And this will also help yield predictions. So based on what you are knowing, you get, okay, if my crops are rich in potassium, phosphorus, nitrogen, then I am going to get much yield. If your analysis is telling you that they are deficient, then you will know where you are losing. And then urban planning, like I said, you can use it for land use analysis. You just pick the Landsat image from maybe USGS, or you can even pick it from the NASA, and then analyze to know the land use, just using it to know the land. So the land use can help you know what is going on in particular areas without you being there. The environment, like I said, how it was used to monitor the illegal galamsey. So forest and water quality, you can just use it to check using the NDWI, the normalized difference water index, to monitor the water quality, and then also check the forest. You can use it just picking the satellite image, putting it in the GIS environment. You'll be able to apply the GIS techniques to do that. Maybe in subsequent videos, I will look at a practical way of doing it using either ArcMap or QGIS. Disaster management. You can use LiDAR to, you can set a core station, a station to detect seismic movement. Let's say a core station at a particular place to detect seismic movement. So this data picked and then inputted into the GIS environment, you'll be able to know the earthquakes. You'll be able to know zones that are prone to earthquakes. Yes, and then also flood and fire monitoring, zones that are prone to fire because of the high sun, and then because of the activities, the economic activities and the social activities that are being done over there, to know based on the data gotten from the remote sensing. You can just use the GIS to process and then notice them with ease. And climatic studies, yes, it is a very important tool because climate affects the economy a lot. Yes, it affects the economy a lot. Without climate studies, you won't be able to know how to manage a lot of things, like the sea level, and then the temperature. So you can use it. Remote sensing can just pick temperature data, imputing it into the GIS. You'll be able to know various places, and knowing the relationship between the temperature and the sea level. Maybe it has a direct proportionality. You can see that, oh, okay, as temperature increases, the sea level is rising, or as temperature decreases, the sea level is rising. Then you'll be able to know that how to keep. Maybe the temperature is being caused by the greenhouse effect, the global warming. You'll be able to know and then see how best you can create greenhouses to be able to curb such things, to improve upon the economic state of the country. Yes, you can do that using just the remote sensing and GIS. So in summary, we looked at GIS and we said GIS just analyzes, visualize spatial data. It also interprets spatial data. That's what it does. Whereas the remote sensing will capture the earth surface remotely. So it is just capturing the earth surface. As it captures, the GIS will analyze. That is what they do. So without the remote sensing, you have to go to the field and capture it yourself. Yes, you can go to the field and capture it yourself. But you going to the field and picking the data yourself is a lot of work and a lot of load. It involves a lot of human resources. Remote sensing can do it with ease and very cheap. And so remote sensing just capture, then the GIS, like I said, GIS deals with the earth, geo. So if you are getting the information remotely about the earth, GIS can do a lot with it. So together, what do they do? What do they do? They monitor, map, manage the earth surface more effectively. We've looked at how they will do land use, land cover, how they are able to check erosion, how they are able to manage climate, how they are able to check temperature, and a lot more. So Conclusion: GIS and remote sensing are foundational in geospatial science. Yes, geospatial science, GIS and remote sensing, they are foundational. Without them, geospatial science will be limited in a lot of areas. And then GIS and remote sensing are two sides of the same geospatial coin. One does this, one, they are all the same in the geospatial science, only that one has what it does, the other has what it does. Together, they will improve upon the Earth analysis. So together, they will support, they support, they support smarter decisions in agriculture, urban development, disaster response, environmental protection, and more. So I will recommend that if you are an agriculture firm into management and then also crop production, you cannot take away GIS and remote sensing. Including them will help you yield maximum yields. If you are already gaining profit, without them, you gain more if you include them, because they are important key. They are important key and they have come to stay. Better start utilizing them, and then we are going to benefit a lot from them. So we are going to end here. In our next video, we will explore raw tools and data sets. We are going to take data sets, explore them. We will take data sets and explore them to see how they work. We will look at the types of the data set. We have the raster and the vector. Look at the vector, explain, go to raster, explain, see how they are used in the software. So we are going to take software, and then we'll get more practical in this tutorial, so that at the end of the tutorial series, you'll be able to use at least one of the softwares, maybe QGIS, to do spatial analysis and then explore more in remote sensing. See you again in my next tutorial. Until then, bye bye.